welcome everyone. Good morning, good afternoon, wherever you are in the world. Thank you very much for joining us to this 8th talk of the EDT seminar series in the second series. Today, we will have also an exciting talk. Thank you, Patrick, for agreeing and accepting to give a talk in the EDT seminar series. Patrick is a labs researcher and advisor at Snyk company. He's notably the inventor and known to be inventor of the term, and he coined the term of DevOps. He started to do so, and he presented the earlier concepts in the Agile infrastructure at Agile conference in 2008 in Toronto. And a year later, he officially organized the first DevOps days in 2009. He also co-authored the book, the DevOps Handbook, well-known book about DevOps. And he has been a big promoter of DevOps ever since. And recently, he's also been working and promoting on DevSecOps to make the world a safer place. We are very excited to host Patrick's talk entitled, Will Models Make a Comeback in DevOps SDLC? So without any further ado, Patrick, I will let you share your slides and the floor is yours.
I like to promote these things and I like to think in analogies, and therefore I'm grateful that I'm invited into this community to talk about digital twins and DevOps. It's deliberately that the EDT community is bigger and they know more about digital twins than I will ever do. I do bring my knowledge of DevOps, and that's how you have to look at this presentation. I've spent a couple of weeks looking at the literature, what I could find, analogies, and this presentation is version 1 of this analogy of things that I found that might be useful and kind of cross-pollinate the two worlds. The original title was, Will Models Make a Comeback in the DevOps SDLC? Because the word model kept coming back, and when I started a long time ago, models were all the rage. Everything had to be specified because it was expensive to put things into production. This is kind of the background why this title came, because I think that eventually through DevOps, more and more models are starting to reappear again. Final disclaimer, this is a thing together. By the end, there's going to be lots of room to give feedback, ideas. I'm just trying to kind of pique your imagination. If you see correlation or kind of any thing that I missed or that you think is valuable, please share at the end. So there's two ways of looking at this. I'm looking at mostly from the world of DevOps because that's the world that I know best, but I'm trying to imagine and I'm trying to put this in the context of the world of model-based engineering. Well, a lot of the examples are things that we learned in the DevOps world and I think can be related to models. When I first, you do your research and I do it through Google, that's what I do. And I look up the word DevOps and models and digital twins. And probably the first paper I came across was something around digital twins, TwinOps, and mod DevOps. And when I looked at the paper, there was a lot of kind of looking at similarities, and there were envy of the speed of DevOps and speed of changes, which is hard in a physical world, and which is ironically because it was the same speed that I was envious from the agile software development world when I started out as an admin. And in the paper, what I tried to do is they kind of try to distill the model and convert it eventually into code. And then through that translation, that code became part of the SDLC. And for me, that sounded very similar to what has happened initially in the DevOps discussion around infrastructure as code. We started the virtualization almost like through the DSL, whatever it was, like CF Engine, Puppet, or Chef. They were all about specifying what we did manually, what we did before in scripts as a reusable model. The instance creation on AWS, the speed of creation, the user creation on the cloud, everything was code. And that has just been expanding. The other day I made a tweet of everything you could think about as code. I think I came up with about 50 different things that eventually turn to as code, but most important, infrastructure as code, policy as code, security as code, the pipeline, and the platform. So I think even if it's not actually code, there is something of a DSL that made it as code as people saw it. And more expansion on the ideas of my reading was that I came across the terms digital model, digital shadow, digital generator, and digital twin. For those familiar with the concepts of digital twins, probably not a new thing. But for me, when I saw the diagram from the feedback loops, I tried to translate this into the three models, continuous integration, continuous deployment, and DevOps. And they're both kind of like continuous integration. One of my biggest annoyances was that they stopped right before production, and then it was a manual thing. Eventually, we moved from continuous integration, continuous delivery to continuous deployment, and that was all becoming kind of automation. And then I think DevOps, what they tried to do is beyond just the continuous deployment, is also look at the monitoring and the feedback of the real world, of the production world, and then bring that automatically into the developer world as well. So I think there's a lot of similarities, and both worlds have been looking at similar things. There's a real object, or the physical object, or the real world, the production world, and they're trying to sync that with a model or another environment, but both are seeking fast feedback, and some of it is manual and some of it is automated. The other thing that immediately came clear is that everyone around around digital twin talks about multidisciplinary teams, which was very similar to breaking the silos in DevOps, and that collaboration aspect with different views on the system, the different view of what is going on in the real world and what is going on in the internal development or kind of model. That is something that was historically breaking into two teams because they're dealing with different problems. But part of the solution of DevOps was breaking those teams or the barriers between those teams and making them collaborate. When you talk about looking at those models and you kind of build these models, one thing that came up over and over again is that there's some business goal and some business knowledge. And sometimes just by looking at the components, that's not really clear. And in DevOps, we learned that we are having so many discussions about building the model that is inside people's head and making that more defined, more the knowledge actually externalized. The most recent examples have been event storming, where we try to express whatever we're describing as software in business terms, or the collaboration between people doing not just pair programming, but doing mob programming. But eventually, it's all about conversation and the shared model and the shared view of the world, but not just the mechanical, technical view of the world, but the business view of the world as well. And most of the DevOps projects that I've seen, they kind of start in this state where everything was done in manual, a lot of metadata during the production process while creating servers, while creating infrastructures. That was all lost because it was not deemed important. And one of the things we saw is that we can use data that's out there, but we're almost trying to reverse engineer the model from whatever is out there that was done manually. And that is typically one of the first steps in kind of the DevOps projects, is like, what's out there? We don't know. Let's try to discover and then kind of build a model of what's out there. And then once we're in a state that we know what's out there, we can start thinking to do plan changes and work from there. And I don't think that's any different from when you have like a model that's out there in the wild and you're trying to rebuild this digitally. There is like a lost metadata and manual actions you're trying to reproduce somehow from the data you're gathering from the real world. And obviously the nice visualizations were possible once you have all that information, but the visualization is just not the technical thing. They're also part of the conversation starters. People see, if they see like, why is this red? Why is this like this? Why does the flow go like that? So even though the visualization is not just there, they have meaning, and ideally they relate somehow to the business value that you're bringing with your digital twin or with your infrastructure. And I mentioned in the beginning that, you know, when I started out, everything had to be modeled by UML. And I don't know whether somehow this got very hard to do, to keep in sync. It was never exact. It was like the discussions kept on going and kept on going. And then Agile kind of put somewhere the wording, we favor working software over comprehensive documentation. And I'm not saying, you know, this is the excuse to say, well, let's just skip documentation and build a product, which has been kind of for many years a little bit the vibe in the community. I think the nice thing about building this model has turned out that by building this model, it became testable and executable. The way documentation changed was that it was not just paper, it was not just a diagram, but you can execute on this. And there's a real kind of revival happening around almost like diagrams as code, where you model and you create the interactive model kind of from what you're coding. And that is kind of, again, a new leap in not just what you're building, but also the knowledge that you're exposing and sharing. And once we had kind of the CI/CD pipeline, so we had the kind of reverse engineered the coding, reverse engineered kind of the infrastructure. This created like a safety net. When we did changes, we could either branch or fork or rebuild the environment, so we could experiment on this. And pretty much ended up in almost like feature branches. Like per extra thing you add, there's a whole clone of the system, obviously not complete, or it doesn't have to be complete, but enough to test what your feature is doing. And that's quite similar when you have a digital twin. You're trying to change something, a new feature, a new extra thing, a new change that you can simulate through that as well. It gives you that confidence and the safety experimentation instead of doing it in the real world or on the real production environment. And this got later expanded to the idea or the notion of dark launches, where we take a subset or a sampling of production, we do the change, and then we can see whether it's successful, yes or no. I think there's a similarity in what we're trying to achieve in both worlds, in the safety of execution and experimentation. But we also learned that just by building versions and labeling all the versions, it's not enough. There's a concept of reproducible builds, and it's not enough to have an artifact. It's not enough to know all the versions of the artifact. The idea around reproducible builds is that you also record the tool chain things have been made with. And I think that's also another part that is happening in digital twins, is that whatever component, whatever part you're bringing in there, you also want to know whether you can reproduce that, and not just by looking at the source, but sometimes you need a whole tool chain to rebuild that source to make it a chain. There's definitely more work than just versioning. And then once we have all the information, we have it versioned, we have the workflow kind of built, when we put things into production, there's this annoying thing that is actually like, whatever we do, there's going to be drift. There's going to be drift between the actual model in the real world or in production and the model we have in our test environment or in our digital twin. And that is the specifications might be different. The inventory, what's out there might be different. The knowledge might be different. A lot of it is drift is everywhere and is continuously syncing, which is a digital twin kind of bidirectional updating. It's quite important in that concept. And even though people were automating the code and deployment, it was important to keep checking whether something was different in production. Very similar what people would do in the IT world, like what's happening and what's not happening. And that we kind of reconciliate the two truths from each other. But sometimes the reproducing of the environment was really hard. And when I saw a talk around co-simulation and co-modeling, it discussed about some of the models are black boxes and we don't know what is happening. And this reminded me of a concept or like a product to local stack, where when you have a SaaS provider like Amazon or Google or another service that provides, you're not able to fork or copy that environment. What they provide you is almost like a local version or a slimmed down version or a testable version in a black box way that you can use to test. So containers and Docker and similar things have been instrumental to kind of create these local black box environments that people can test against without having to know all the details. Again, a similarity between both environments. And I think this one is obvious, like open, open, open. It has helped progress the communities. It has helped the things. And the reason why that is about the sharing. Like we shared the infrastructure as code recipes. We shared the monitoring dashboards we had. Like all that sharing was instrumental to improve both worlds. And eventually this even led to more and more the idea of interchangeable components. And I think the best example in the DevOps world is Kubernetes. Like while you could build the whole Kubernetes before Kubernetes existed with all the components, it became like a standard way of coupling like load balancers, servers, storage, and all these things together. So they kind of made this into an interchangeable model where you say, I have, for example, a load balancer or an ingress controller, and I can swap in and out different components depending on what I need or the specifications I need. Is it just for testing? Is it for 5 users? Is it for 1,000 users? Am I willing to spend a lot of money or less money? And this is very similar to, I guess, in the component world, where you need to understand the specs of your components that you use and the tolerances in which your component can operate. But the fact that you can interchange them and like replace them at will was a very important thing. I think Kubernetes is the manifestation of that in the DevOps world. And together with these kind of almost like components and reusable parts, there also became a way of looking at best practices of doing things. The catalog is not just about, we have these components, we know how to build them, but we also have to look at the usage patterns. And in this example, there's like the DevOps topologies or the best practices for open source maintainers. There's a lot of best practices that get codified in your model as well. And that's not just the components or the technical parts that you're assembling there. Eventually, we also learned that like we have the components, we know how it's built, but we also using it almost like an approval flow. When we're not exactly sure, or we kind of ask approval from another person to do the change. And because we have the safety environment, they can explore, they can test, they can see what the change will have impact for, and we kind of have this almost like conversation, which is deploy, discuss in a way that it gets to production. And the nice thing is that most people think about, oh, with infrastructure as code, I can see what the impact is. Am I going to create like a stack of 5 servers? But there's additional benefits. Like once you have the model of this kind of whole infrastructure, you can do other aspects because, for example, cost is a very important aspect of an infrastructure. And when the person changes the model, changes the code, they can immediately see the impact on other parameters. Like in this case with infra cost, they can see whenever they change something, what the impact is on that infrastructural change. And I think what we learned is that it's not just about providing the model, being able to reproduce this, but the self-servicing aspect and the instant feedback was important. If a user has to wait for a new environment, has to wait for a digital twin to do their own experiments, there will not be that much incentivized to do their change. And that's kind of what you would be looking at, is the self-servicing. And I often say that's the difference between traditional IT, which was you could ask something, and if they're good, they're going to be fast. But self-servicing has been crucial in the DevOps change in companies. And I mentioned cost about doing the change, but once we have the model of what servers are running, what kind of infrastructure you're running, how your Kubernetes looks like, we can do like more intelligent things. Like we can look at the capacity of your users and your usages. So sometimes we can like use spot instances, which is kind of leftover capacity. And in factories, that's the same. You look at optimizing the cost, like to what production line am I sending things, and then I change things. And you have, once you have that model, you can start using the attributes or the properties to kind of do new things. And what's interesting is that there's the feedback coming back to the model, because when you change, you say, I want to launch a cluster with 15 servers, and then your reasoning or your capacity management like spot.io will change this based on the demand. Your model is not anymore 15, but the real world has changed maybe to 25, and they're running on a different set of servers. This feedback initially was hard for the inventory systems to keep up with. Can you keep the model in sync with the changes that your intelligence is kind of doing? And of course, we talked about the models of the servers, and you would think like, oh, I'm going to spin up 5 servers, I have 10,000 users or something like that. But Netflix learned, for example, that models lie. And there was a practice about they would spin up a new server on AWS, they would benchmark it. And if the benchmark is okay, only then they would use it. So it's interesting because the model would say just use 5 servers or 1 server, but they would actually verify that this in production, and they would get the feedback from only by running it in production and in the real world. And because we now have that feedback system and we know what is the traditional normal kind of behavior, we could start looking at the usage and forecasting. Like the whole winter's confidence bonds will tell you, like, is this normal usage? And it's a very simple usage of forecasting, but it kind of like allows you to do a preventive or create more capacity, because we know there's going to be usually a bigger load after 8 p.m. or something like that. So this really helps, but also it helps you to look at your outliers. So with the monitoring system, you know what is normal, what's not normal. And if it's not normal, you can be alerted, or you can even act on this automatically there as well. And we have the model of all the servers, we have the components, we're building it, we're deploying it. But there is, for example, a lot of the digital twins are used for testing or test for failures or what if scenarios. And chaos engineering introduced that into DevOps, where we would randomly terminate instances in production, but it's not really randomly. The random is still using the model by saying, for example, there have to be always 5 systems running, or I can only do this when I have like a load of 50% of my users on that server. So even the fault tolerances or the test for failures uses the model in chaos engineering from what's in production and what is in the model that you have defined. And that's maybe a little bit of a sidestep, when things fail or when we need to upgrade the whole world, there's still a lot of communication that needs to be happening. And in games, they have a concept called live ops, and it's usually a team that helps with these bigger changes and communications. But when it's a small change, they are kind of like the release managers that do the discussions and help the users change things. And in a digital twin, when there's a bigger update, there's a lot of communication happening to whoever is using the digital twins. And it's kind of like, I think it's similar to live ops, where this kind of release management or managing the big world change is something that needs to still be done by humans. From chaos engineering, we kind of moved into resilience engineering, because now that we are able to simulate failure, to simulate the environment, to fork the environment, to reuse the model, we can do resilience engineering. And the biggest aspect for resilience engineering is that we are learning from failure. And we use that for training. And a lot of the digital twins are actually used not just for predicting what's going to happen in production, but also predicting how humans have to deal with a certain problems, or how they will learn from failure, because they can replay scenarios and see if it has been solved by a certain thing. So you see the two worlds kind of almost coming together, whether it's resilience engineering comes from airplanes crashing and looking at root causes, or like different things and aspects, and learning to prevent this, and also learning how people would have to respond in certain scenarios. And this is where a digital twin can really help, almost like in a similar simulator, and see how we can improve ourselves to react on these failures. And then maybe as almost as a next step, when DevSecOps got introduced, we started to see that it was not just the containers that needed to be deployed or the infrastructures, but the application itself. And we started to look at the whole bill of material of the application, because when you want to know whether your application is secure, what you do is you look at all the components, and there has been the analogy of the software bill of materials, in a way that we know what everything is composed of. And without all the previous work of inventory or looking, versioning, this would have been really hard. But within DevSecOps, to see if something is secure, we can actually look at all the components quite nicely. And maybe what's ironic is that, you know, at a certain time with the containers, microservices became the new rage, and all peoples were creating everything as an API. So it started out as code, and then it was like everything needs to be a service. But we had the same problem. People had to first build the APIs. They all did it manually. And then all of a sudden we said, well, what if we just create a specification or a model from the application and the API? Then all of a sudden we have executable documentation. We can see who uses what. We can see what like input and output parameters go. And then we saw the same movement happening, is that we start to have an inventory of all the API services running in an environment, in an enterprise. We start translating that to model. We have the model that can create the tests, and then we move from there. So even though we would have learned this by looking at DevOps, we had to relearn this for an API. And I'm pretty sure in digital twins, you know, we all of a sudden we see, oh, why did we do this part again all manual, and why did we not have a specification? I think part of this is that there's a discovery process. Like, you're learning the problem, and then once you better understand the problem, you start to be able to document and to model it. And I think we're always going to hit that kind of problem in the both worlds, where we're not sure what the model is, we're just experimenting. Then from the experiments, we learn what the model is, and then we can kind of more like do this more structurally. And I'm already mentioned in DevSecOps looking at all the components of the environment of an application, and to see whether that's secure. And I came across this blog post about those primitives and complex parts or sub-elements in digital twins. And what the paper tries to explain is that a primitive and a complex, they might have different characteristics. And for example, in supply chain security, imagine you have all the components of the software, you have all the build chain, everything that has been made. It's really hard to say whether the whole environment is secure, yes or no. If we just look at all the components and they're secure, yes, probably the whole environment is secure. But if one of it is not, we can't really predict whether it's still secure, yes or no, because the whole environment might have different characteristics. And what's interesting is that it's not just the components we own, it's also the components that third parties, whether that's a SaaS service or an open source component, how they are built, how they are secured, that are important to decide whether something is secure, yes or no. So the main important part is that the behavior of the complex system is different than the different parts of the primitives in the model. And it's, again, emerging behavior that we're looking at. The nice thing is that the more and more we define of that chain, the more we can start simulating on that part. And then maybe one of the final stretches is that if, I work at Snyk and we do scanning of code for vulnerabilities, whether that's your container or your code. And we try to think whether you as an organization are secure. And what we learned is that while just looking at your tech, that is not enough. We need to know how the tech is used in your organization. It's almost like we want to understand how a customer uses this library, uses this application. And part of it is almost like we said, reverse engineer the technical parts, but we also have to reverse engineer the organizational flow and the behavior of the people there. I think this is something that if we want to make decisions on behalf of the customer, whether they should block a certain vulnerability, yes or no, whether they should fix something, yes or no, we need to have more and more in a broader view. And it's just not going to be solved by technology only. We need to almost have a virtual twin of their organization. And I think almost like in sales and marketing organizations, you see this, that they kind of track all the movements of the customer. And I think if we want to have this more consolidation of the technology changes and the organizational twin, if you want to call it like that, that both blend together. And I think that is manifested a lot in the digital twin when they talk about the smart ecosystem, the world where things live in. It's that there's also a human side of the model that you have to reflect on and to see what happens. So where before my examples were more about like, if I change this technical component, what will be the impact? Maybe now we can, have the pipe dream about if I change the product, what will happen to the customer? Will they still want to be working on this? Can we predict this behavior? So it started to be almost like analytical mixture of analytical and operational environment that we're trying to look at, to give better recommendations for the service that we're providing. And I think one of the things that bogged me a little bit is whether when I looked at DevOps and modeling in DevOps, everything was kind of already digital. So I don't know whether in the definition of digital twin, we can really say a physical object in the digital world, but maybe you have to think about it as the digital native twin, where the digital twin is the digital twin of the production environment or the test environment. I'd love to hear from you how you think about these problems. I probably don't know a lot of the domain language in digital twins to express this well, but I think there's something there that both worlds are kind of like fusing together. And I think that's how I would like to end in this presentation is I've shown you a lot of the similarities. I do not have enough expertise in the digital twin world itself in the industry, but I'd love to hear your examples on what resonated. What do you see is different between the digital twin or the aspects that you heard about modeling in DevOps? One of the things that like I am thinking about is that like the sustain is managing models sustainable still in DevOps. It's so ephemeral, lightweight, it changes. Like who wants to model this for a longer period? Maybe that is for kind of the SaaS providers who will live and longer, kind of like industrial components where they are heading. So maybe that is a good extension and the reason why this is going to happen. And the other part is I love to hear how in the kind of the digital twin world in the industry, how enough incentives were created for vendors, because they like to shield things, SaaS, shield their services. So why would they expose this information? Why would they kind of provide this to you? Is this because of a play of, if there's enough competition, this works. If there's not, it doesn't. So I'd love to hear from you. You can reach me, probably easiest is through Twitter, at Patrick Debois, or we can now have a discussion, or you can find me through the organizers to give some feedback.